So we're going to do day 2 of this stuff that we started yesterday. So right now I get it. It's probably because you just had yesterday, and I just dumped a bunch of stuff on you yesterday. And so it's probably like this, where you're like, do I do this? Do I do that? I got all these questions. I don't know. But hopefully after today, it's just keep swimming, swimming, swimming. Okay? Okay? So hopefully after today it becomes this. So one quick warm-up problem here. So first off, I would like you to list me the possible zeros of this function, and then I would like you to find me the 3 zeros of this function. Okay? So list, and then find. So to get my list, Luca, what do I do?
You gotta take the factors from the last term and the first term.
Okay, and I do what? So what are the factors of the last term?
3 and 1, 1 and 3.
Okay.
Plus or minus.
Okay. Factors of the first term?
1 and 2.
Okay. So what do I do with red numbers with the green
You
numbers?
gotta divide the red number by.
Okay. So that's going to be plus or minus 1, plus or minus 3, plus or minus 1/2, plus or minus 3/2. Yes? Okay. Did anybody, when they were going through, did anybody find a 0?
Yes.
What do we got?
3.
3? Okay. All right. So let's try 3 first. Synthetically dividing in to 2, -5, -4, and +3. Drop it like hot. 6, 1, 3, -1, -3, 0. Love it. Okay? I'm actually going to move it, though. I love it so much, I'm going to move it. What does that mean? 3 is a,
0.
which means what? Which means what? Is a factor. Okay. So that means we can make f of x become x minus 3 times what? (2x squared) plus 1x minus 1. Okay, now what? Factor blue? Okay, does blue factor? To what?
I got 2x minus 1 and x.
Do we agree with that factorization? Well, that would give us here -x, here positive 2x. Those two combine to be positive x, yes? 2x times x is 2x squared. -1 times positive 1 is -1. So, yep, I would agree with that. That's going to mean that f of x is now x minus 3, 2x minus 1, and x plus 1. Yes? Now what? 7 equal to 0. So I get my three zeros are -1, 1/2, and +3. Agree? That's what I got. Questions, comments, concerns, clarification? Good times. All right? So, from yesterday, our steps to finding rational zeros. What was our first step from yesterday? Find all the possible ones, right? Okay. So we find all the possible factors by taking factors of the constant and dividing it by factors of the lead coefficient. Okay. That gives us a whole list of them. Now, sometimes that list is kind of long, but it's still a list. Sometimes, like in the last one, it's only 8 long. Makes it easy. All right? Then what do? We find one, right? And here is where yesterday I was hearing a lot of complaints because, why can't you just show us the shortcut? Okay, right? I get it. I heard it. Okay? I heard it. So today I'm going to show you the shortcut. Okay? Because what we can do is we can graph this function, and the zeros of a function are the places that it crosses the x-axis. So if we can see where it crosses the x-axis, then we can narrow that down to just in those particular spots. And those are the zeros. So it gives us, we don't have to guess and check, we can just do. Okay? So you will need your Chromebooks out for the next example, just so you are aware. Okay? So if you just wanted to get them out and get them fired up so you understand how to do that, that'd be great. And then our last step is we factor until we can't factor anymore, and then we solve, and that solving part might include using the quadratic formula. Okay? All right. Let's do one. So, here we go. We want to find all the zeros of this function. So step 1 says we got to find all of our possible zeros. Okay? So what are the factors of 42? 1 and 42. 2 and 21. 3 and 14. 6 and 7. Okay. What are all the factors of 2? All right. So my list then all the red numbers divided by 1. All the red numbers divided by 2. Right? Okay. So now, what I would like you to do is now I'd like you to go to Desmos on your Chromebook, okay? And I'd like you to graph this function, 2x to the 4th plus 5x cubed minus 18x squared minus 19x plus 42. So on your Desmos, you should see something that looks like that. Okay? And so what we need to do is we need to find, or so how you read this is here are the 4 zeros of this function. So this function has 4 zeros. There's the 4 zeros of the function. Okay? We just have to narrow those down to whatever they are. Well, this one looks like it's pretty easy to find. What do you think that one is? -2. This one looks like it's pretty easy to find. What's that one? (1.5), which is 3/2, because 3/2 shows up on our list. So that one is 3/2. The other two don't look like they're pretty easy to find, right? Okay. So let's start with those, with one of those. Which one do you want to start with first? -2. All right. So if I plug in, or so if I synthetically divide -2 into my function, 2, 5, -18, -19, and 42, 2, -4, 1, -2 is -20, +40 is 21, -42 is 0. So it works out. So that means that -2 is a 0, which means that, what's the factor? X plus 2. Right? So now my function can be written as x plus 2 times 2x cubed plus x squared minus 20x plus 21. Can blue be factored? Doesn't really matter because we have another 0. Okay? We have 3/2. So we can take this new factor, which is this factor from here, and we can run 3/2 on it. Extend my page now here. So 3/2 on 2, 1, -20, and 21. Two, it was our other 0 that we identified from our graph. Two, 3/2 times 2. 3. 4. 3/2 times 4. 6. -14. -14 times 3/2.
Or -21.
-21. So that means that 3/2 is a 3/2 is a 0, and x minus 3/2 is a factor. So now f of x can be written as x plus 2, x minus 3/2, and 2x squared plus 4x minus 14. Can I do anything with 2x squared plus 4x minus 14? We divided it by a linear factor again. Can I do anything with the blue? What? Take out a 2. Can I do anything with x squared plus 2x minus 7? Nope. Okay. So f of x in completely factored form then is 2 times x plus 2 times x minus 3/2 times x squared plus 2x minus 7. Because you don't have to guess and check anymore. This is just a long problem. Yeah. Because 2 always goes up. Numbers always go up front. Yeah. Okay. Now what?
Find 0.
Find 0. So I set them all equal to 0, right? Can 2 ever equal 0? X equals -2. That's the one that we found first. X equals 3/2. That's the one we found second. What do I do with x squared plus 2x minus 7? Quadratic formula. So now we've got a quadratic formula of that one. Agree with that?
Yes.
Talk to me, honey. What do you got? How did I get 32? That's a great question. I'm glad you asked. Okay, right? Because inside it's b squared, right? So that's 4 minus 4 times a times c. 4 times 1 times -7, right? So it's 4 minus negative 28, which is 32. Other questions on that? Don't put them in a calculator. We don't use calculators at all. We saw it off of the decimal. Nope, it's a graphing tool.
So how do you graph it?
You'd graph it. You'd have to graph the function.
Wonderful.
Yep. So our final answer, my 4 zeros are negative 2, 3 halves, and negative 1 plus or minus 2 square roots of 2. Okay? Go for it. So factors of 25 are this. Factors of 1 is 1. So my list is this. Yes?
Yeah.
So then we put it on the Desmos.
First 0 to 5.
So then we put it on the Desmos. Yes?
Yes.
What do we got for zeros?
5 and negative 1.
5 and negative 1. So it works. Because we have zeros. Right?
Yeah.
Alright, which one you want to do first?
5.
5? Okay.
Does not work.
So we're doing 5. So we go 1, 0, negative 16, negative 40, negative 25. 1, 5, 5, 25, 9, 45, 5, 25, 0. Mine works.
What? It's all for
You got
You forgot the 0. So this is, bring it back in.
That's our 0.
This is our 0.
The factor is x minus 5.
The factor is x minus 5.
And let's do 1.
Okay? So now what does f of x become? That's fine. That's fine. That's what we said yesterday. It depends on which one we do first, and that's going to diverge us. But in the end, we're still going to end up in the same spot. Okay? So now what?
We do 1.
Now we do 1, but we do 1 on this function. Or we do negative 1, excuse me. So we're going to do negative 1 on 1, 5, 9, and 5. 1, negative 1, 4, negative 4, 5, negative 5, 0. So that means that negative 1 is a 0, which means x plus 1 is the factor. Which means my function is now x minus 5 times x plus 1 times x squared plus 4x plus 5. X squared plus 4x plus 5. Is it factorable? No. What's the easiest way that we can tell that it's not factorable? Even easier than that. What can I look at to determine if it's factorable or not? Look at my graph. How many times did it cross the x-axis? Twice. If it was factorable, it would have crossed 4 times. Okay? So I don't even need to worry about trying to figure out if it's factorable or not. I already know it's not. So what does that mean? It's not factorable. I promise it's not, because it didn't cross 4 times. So now I get the zeros, right? Okay? So x minus 5 gets me 5. X plus 1 gets me negative 1. X squared plus 4x plus 5. What do I do with that? Quadratic formula. So we're going to have x equals negative 4 plus minus the square root of 4 squared is 16 minus 4 times 1 times 5 all over 2. 4 times 1 times 5 is 20. 16 minus 20 is negative 4. The square root of negative 4 is plus or minus 2i. So our answers are negative 1, 5, and negative 2, plus or minus. Questions, comments, concerns? Imaginary roots come in pairs. As soon as we saw the graph only crossed twice. We automatically knew that there were 2 imaginary roots. Because there has to be 4.
So this is like next unit technically, right?
No.
No? But this won't be on the test.
Yes, it will.
Okay, never mind. But we can't use that.
But you can't use decimals. I kept the numbers small
Okay.
so that your lists aren't huge.
Okay.
Whereas like on this one, our list wasn't very big.
Right.
So we didn't have to use decimals on this one.
Right.
We could have, because at most we would have tried 6 numbers. And in synthetic division, that's not that bad. Okay. Yep. 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 Okay. Before you leave, again, make sure you turn in your goldenrod worksheet, and you will have a quiz on Monday.